Good morning, everyone. So today we're going to be doing a review of section 8.3. So we're going to call this 8.3 day 2, and it's going to be on exponents where we were doing the quotient rule, which is division. But we're also going to tie in some multiplication as well towards the end and powers of powers, just to do a little bit of review. So this first problem, we're going to be working on. All these highlighted ones are going to be done in class, and then the remainder of this is going to be your homework. So please take a picture of that and put it into Google Classroom for us. So this first problem, we have x squared y squared over 4x squared y to the negative 2. Well, the first thing I recognize is that there's x squared divided by x squared. And what's anything divided by itself? Well, that's 1. So I can just go ahead and cross those out. So now I have y squared over 4, because this x is gone too, 4y to the negative 2. Well, when you're dividing, what do you do to your exponents? You subtract them. So y to the second minus, so y to the second, and then y to the minus negative 2. So that's going to be y to the second minus negative 2. You keep your base, you subtract your exponents. So the bases were y, the first exponent was 2, and then you subtract negative 2. But double negative turns to positive. So that really becomes y to the fourth. So now we have y to the fourth over 4. And that's our final answer. All right, next one. So I see m to the 0 power, but what is anything to the 0 power? It's 1. So that can also be excluded. So really I just have, because n times 1 is just n, I have n over 4nm squared. Well, now I recognize that I have n divided by n, and what's anything divided by itself again? 1. So now that's also gone. So there's nothing in the numerator left but 1 times 1, right? So there's still 1 in the numerator divided by 4m squared. And that's your final answer. Next problem we're going to be doing, let's see. So we have x squared divided by x to the negative 2. So remember, keep your base and subtract your exponent. So x squared minus this exponent, which is negative 2. Double negative turns it to positive. So you end up with x to the fourth. Okay. And then same idea here, right? So we have y to the negative third minus y to the third. No double negative here. This is just negative 3 minus 3, which is like adding a negative. So that's y to the negative 6. Okay. And then we still have 4 thirds. That means that 4 is in our numerator. 3 is in our denominator. Now, when I simplified my x's, I got x to the fourth. And when I simplified my y's, I got y to the negative 6. Now, we put those in the numerator because if we put them in the denominator, that would be like 1 over those values. Instead, it's this value over 1. Now, I want you guys to recognize that you are allowed to leave negative exponents right now, but in tomorrow's lesson, we're actually going to be showing you how to simplify those and figure out, well, what happens to them. But for now, you are welcome to leave them. Next one, right off the bat, I see k to the 0, so I'm going to just get rid of that real quick. And I see 3 over 2, so I'm going to put 3 over 2 before I forget. And now I'm going to work on my h's. So I have h to the negative 2, and there's nothing else there. So it's going to stay h to the negative 2. And again, that's all right for now. Tomorrow we'll move on, okay, and get rid of those negatives. But for now, we're fine. And then we have j to the fourth, oopsies, I wanted a different color. J to the fourth over j to the fourth. But what do you notice? Well, we can just cross those out. All right, so what's left then? Just k to the fourth in the denominator. And remember, it stays wherever it is. Next problem. All right, so here's where we're tying together a few different things. First, let's go ahead and look at our numbers. We have 3 times 3 and then divided by 4. 3 times 3 is 9 divided by 4. So we have 9 over 4. And then let's go ahead and start multiplying the x's. So we have x to the third, but there's no other x to the third in the numerator, right? The only other x's that we see are in the denominator. So we have x to the negative fourth, rather, and x to the negative 4. So let's see what that's going to look like. So that's really x to the third is in the numerator. And then what happens when we multiply exponents? We add. So we keep the base, which was x, and we add the exponents. So negative 4 plus negative 4 gave us negative 8. So x to the negative 8 is in our denominator, and x to the third is in our numerator. So just to make this a little bit bigger so that it looks like that's an exponent. And now, since it's division, what do you do with division? You subtract your exponents. So that's x to the third minus negative 8. Double negative means you turn that to addition, so you end up with x to the 11th. And that goes in our numerator, x to the 11th. And then we work on the y's. The y's. So we have y to the second times y to the fourth divided by y to the second. Now, we could do this two different ways. We can go ahead and multiply those and then divide, or you can recognize that those y squares cancel right from the get-go, right? And then leaves you with y to the fourth alone in the numerator. So our final answer is 9x to the 11th, y to the fourth, all over 4. Next problem we're going to work on are ones that have powers of powers in there. Now this looks super complicated, but I want you to recognize that this entire parenthesis is being raised to the exponent, and that exponent is actually 0. So what is anything to the 0 power? It's 1. So this whole numerator turns to 1, and there's no work to be done in the denominator, so that's 2x to the third in the denominator, 1 over 2x to the third. And that is your final answer. Unfortunately, they're not all going to be that easy, but I do want you to recognize that you can easily simplify a lot of these by recognizing the 0 exponent rule. So let's move on to the next. Let's first look at r to the negative 2 being raised to the negative 4. Now, when you do a power to a power, what do you do to those exponents? You multiply them. So that's really r to the negative 2 times negative 4. And what's negative 2 times negative 4? Positive 8. Okay, and now let's look at the second exponent that we have here. Now, just like before, it's important that you recognize what is being raised to that exponent. In this problem 13, that entire numerator was raised to the exponent. Here, this parentheses tells us that all of that is being raised to the negative 4. Well, that includes this coefficient of 2. So now we have 2 to the negative 4, and then r, multiply those exponents. 2 and negative 4 get multiplied to give you negative 8. Now what is 2 to the negative 4? Well, we're going to talk about that again tomorrow, so you can just leave that for now. All right, so let's rewrite our numerator because we just found r to the 8 was this portion here. And times, right, because that's being multiplied to this, 2 to the negative 4, and then r to the negative 8. Oh, so something special just happened. Let's see if you recognize it. And then let's compute our denominator. R to the third being raised to the second, multiply those exponents to give you r to the 6. Now, here is our little shortcut. R to the 8 times r to the negative 8. What do you do to your exponents when you're multiplying? You add. But what is 8 plus negative 8? It's 0, right? So, and what is r to the 0? It's 1. So basically, those cross out, and you are just left with 2 to the negative 4 over r to the 6. 2 to the negative 4 over r to the 6. Sorry, that's awful looking. Let me erase that. Okay, and that is our final answer for now. Again, we'll take care of those negative exponents at our next lesson. And then this is the last problem we're going to be doing together. First thing we want to do is the parentheses. So here we have everything in this parentheses is being squared. So that becomes 3 squared, v squared, and then u, multiply those exponents, u to the 6th. And then I'm just going to rewrite this fraction. So I have 2 u to the 5, v to the 3rd, u to the 2nd over these purples. 3 squared, though, is 9, so I might as well just write that. V squared, u to the 6th. And now let's go ahead and combine any like terms that we can. So in this numerator, we have u to the 5th and u squared. So we can merge those together, and there's nothing we can merge in the denominator yet. So equals, we still have 2, u to the 5th, u to the 2nd becomes u to the 7, v to the 3rd stays over 9 v squared, u to the 6th, and last but not least, we can now, so u to the 7th and u to the 6th, we can now simplify those, as well as v to the 3rd and v to the 2nd. So remember, when you are dividing, you subtract your exponents. So I still have 2 over 9. Now I have u to the 7 over u to the 6. We know we have to subtract them. You have 1 left over when you do that. And where is it left over? In the numerator, there's more. So the u is left over in the numerator. And then for the v's, v to the 3rd, v to the 2nd, subtract them, you have v to the 1. And there are more left over in the numerator for that one as well. So that becomes 2uv over 9. All right. Let us know if you have any questions. Take care. Bye.